Hello again. Welcome back to Algebra 2 Notes with Miss Faust. This is lesson 3.6.5, and what we're going to look at today is how we divide polynomials. So last time we looked at adding, subtracting, and multiplying. Now we're just moving on to the next step, which is division. So first of all, the thing to think about is that factoring is a simple way of dividing polynomials. So if you have something like x squared plus 5x plus 6, and you wanted to divide that by, say, x plus 2, what you're really looking at then is you're looking at x plus 2 times something else that gives you back x squared plus 5x plus 6. Right, because division is undoing multiplication. So whatever this is equal to is going to be the same thing that goes in that set of parentheses. So this answer to the division problem is the same thing that would fit right here. So if we think about that, if we look at the second part, we can think of two things that multiply to 6 and add to 5. Hopefully you can think of 2 and 3. So we already have the x plus 2, so this would be x plus 3. So we also know then that x squared plus 5x plus 6 divided by x plus 2 equals x plus 3. So you have done some division of polynomials before, we just haven't called it that. And the thing is, we can't always factor. So if we don't have an x squared term in front, if we have a higher polynomial, then we're going to have to do something more with these in order to do our division. So what we look at then is what we call long division of polynomials. And this is very similar to long division of numbers. I know some of you learned long division in elementary school, some of you didn't. We did a little bit of it in class last time just to sort of give you an overview. Hopefully you can take those ideas and start to apply them here to the polynomials. And if you didn't understand it with numbers, you might still get it with polynomials. Lots of times people are like, oh, now I kind of get it. So be patient with yourself, and I think that you will figure it out. So example 1. And what I'm going to try to do is go through the example first, and then I'll give you the steps. Sometimes it helps if you've seen it once. Then you just understand the steps a little bit better. So our first example, I can't find, of course, because that would be far too easy, but you're catching up anyway and writing things down and writing them down and writing them down. And oh, Miss Faust, what has happened? Okay, here's example 1. We have x cubed minus 3x squared plus 5x minus 3, and we're going to divide that by x minus 1. Okay, so what we want to do is we want to put this x minus 1 on the outside of our division box. X cubed minus 3x squared plus 5x minus 3. So just like with division of numbers, when you look at how many times the first number goes into the first term, we're going to do the same thing when we're dividing polynomials. So the first thing we're going to look at here is we're going to ask ourselves, how many times does x go into x to the third? Or another way to look at that, I just like to keep track of these sort of supplementary steps on the outside, is we think about what's x cubed divided by x. So my x cubed came from here, my x came from here. Well, x cubed divided by x, so 3 minus 1 is x squared. So that x squared is what I'm going to put on the top first. So first I divide. Then I take what I divided and now I multiply it, and I have to make sure I multiply it by both pieces of this. So I need to do x squared times x. That gives me x to the third, and then I need to do x squared times negative 1, which gives me negative x squared. And what I want to do now is I want to subtract this whole thing from what's right above it. So notice I'm lining up the terms, and since I'm going to subtract everything and I'm subtracting a polynomial, really what that means I want to do is I want to change the signs of both of those. So first we divide, then we multiply. change these signs. Now we're going to just combine like terms going up and down. X cubed minus x cubed is 0. That doesn't give you 0. You did something wrong, and you got to start over. You always should get 0 from that first part. Negative 3x squared plus x squared is negative 2x squared. So that's what I get when I combine those. And then I bring down my next term. So plus 5x. Now I'm going to look at x minus 1 dividing into this part. So I don't ever go back up to this. I always go to whatever I have left down here. So negative 2x squared divided by x. Well, that's negative 2x. Basically, my exponent's just going down by 1. So at the top now, I'm going to put minus 2x. So I divide it again. Then I multiply. Negative 2x times x is negative 2x squared. Negative 2x times 1 is, negative 2x times negative 1 is positive 2x. Again, I need to go through then. I need to change the signs because these things have to be subtracted from these. So this becomes a plus. This becomes a minus. So negative 2x squared and 2x squared is 0. Again, that should always be 0 or you did something wrong. 5 minus 2 gives me a 3x here. 5 minus 2 is 3. And then I bring down that last minus 3. So then I say to myself, okay, how many times does x go into 3x? Well, 3x divided by x is just 3. So my number on the top is going to be a plus 3. I multiply. 3 times x is 3x. 3 times negative 1 is negative 3. I change the signs, remember, because if we try to subtract these now, we wouldn't get zeros. So I change that to a minus and that to a plus. 0 and 0, that's a good thing. That means I have no remainder. This answer on top then is the answer to this problem. So let me find a different color. So this divided by x minus 1 equals x squared minus 2x plus 3. Now, just like in other division, we won't always get zeros at the end, but I'll show you what happens when we come to one of those. For right now, this is just all we need to do. So this is our final answer. Because we didn't have a remainder, the fact that there's no remainder there means that x minus 1 is a factor of this polynomial, because we can take that polynomial and we can divide it by x minus 1. So that gives us a factor of x minus 1. We're going to go on now and look at what the steps are, so I'll write those out for you, and then we'll continue. And now, magically, the steps for dividing polynomials have appeared in front of you. So I'm not going to have time to do the steps, and I'm not going to have room to have the steps and the problem on the same page, but take a minute and copy down these steps, and that way when we go through the next problem, I can tell you what step each thing is, and you'll get the idea better. So the first step we always did is we divide the leading terms, also known as first divide. Then we multiply whatever we had on top by the stuff on the outside. Then we subtract. The way I think of subtract in my mind is I think of draw the line, change the sign. So a little rhyme to help me remember that. So I draw the line underneath the term and then I change the signs of everything and combine them. I bring down the next term, so the next one from the original problem, and I repeat steps 1 to 4 until I run out of terms. Once I've run out of terms, then I either have a remainder or I have the answer to my problem. I have a 0 left, which means that it's just the answer. Okay, so example 2. Which one do I want to do next? I will do this one next. So for example 2, we'll do x to the third plus 6x squared minus x minus 10 divided by x minus 2. So hopefully by now you've written down those steps and you're ready to start doing another example with me. So I put x minus 2 on the outside. I put x to the third plus 6x squared minus x minus 10 on the inside. And I start with step 1, which was first divide. So when dividing, I divide x to the third by x. You can do that in your head, that's fine. If not, write it down. X to the third divided by x is x squared. So up here I put x squared. Then multiply. X squared times everything out here. X squared times x is x to the third. X squared times negative 2 is negative 2x squared. Now I'm on to step 3. Draw the line, change the sign, also known as subtract everything. So x cubed minus x cubed is 0. 6x squared plus 2x squared is 8x squared. I've now subtracted step 3, so now I go to step 4. I bring down the next term, which is this negative x. Make sure you keep the negative with it. That's important when we do these problems. Obviously, positives and negatives are not the same. And now we go back to the beginning. First divide, so we do 8x squared divided by x. I don't know why I'm changing colors, but you know. 8x squared divided by x is just 8x. Basically, the exponent's going down by 1 because this has an exponent of 1 on it. If I had a different exponent, it would be different. Put an 8x up here, so 8x times x is 8x squared. 8x times negative 2 is negative 16x. Now I subtract, also known as draw the line, change the signs, and combine like terms. That gives me 0. Negative x plus 16x is 15x. Bring down the next term. I have a minus 10. So now I need to do, yeah, that's right. Now I need to start over again. Step 1, divide 15x divided by x. So 15x divided by x is just 15. Notice these numbers are always the ones that go on top. So I put plus 15 there. 15 times x is 15x. 15 times negative 2 is negative 15, not negative 15, negative 30. Draw the line, change the signs. 15 minus 15 is 0. Negative 10 plus 30 is positive 20. Now I look at this and I realize I don't have anything else to bring down. So since I have nothing else to bring down, this is my remainder. So really what I want to do, the remainder, means that I have 20 divided by x minus 2 left. I can't actually divide 20 by x minus 2. So what I do is I write plus 20 divided by x minus 2. 20 comes from there. The x minus 2 comes from there. So I'm showing that all of this divided evenly, but this part did not. So the answer to this problem, which I'm just going to write in the other pen because it'll fit better, is x squared plus 8x plus 15 plus 20 over x minus 2. And what that means is x minus 2 is not a factor of this polynomial because it doesn't divide evenly. Because we have a remainder, that tells us that it's not a factor. If we had no remainder, then we'd have a factor. But anytime we have a remainder, nope, not a factor. Let's do one more example. These take up a lot of space, so I'm just going to make sure I have plenty of space here. So one more example, and we will do more examples of this in class as well. Don't worry. You'll have lots of chances to get good at this, and it's something that a lot of people eventually start to really like because it's procedural. Once you get the procedure, you just repeat the procedure over and over again. So for example 3, we're going to do 2x to the third minus 10x squared plus x minus 5 divided by x minus 5. And just so you know, we won't always have just x's and numbers over here. I'm starting off with those so you start to get the idea, and then in class next time we'll look at some more complicated examples. Also here, notice our exponents are going down by 1 each time, 3, 2, 1, 0. If that wasn't the case, like if this didn't have an x squared term in it, when we write out the division problem, we'd have to write 0x squared in that space, because you have to, when you write the division problem, you have to have a space for each exponent inside this box. We have them all here. I'll show you an example of that in class next time. Again, I can't show you every example in one short little video, so just to get the basic idea is what we're doing here. So first divide. Remember, we divide the outside terms, so 2x to the third minus x. 2x to the third minus x is 2x squared. So on the top here, I put a 2x squared. Then I multiply. 2x squared times x is 2x to the third. 2x squared times negative 5 is negative 10x squared. Draw the line, change the sign. That gives me a 0. Negative 10x squared and 10x squared gives me another 0. So this is an interesting case, right? Because we have two zeros there. So we could now bring down the x. Look at how many times x goes into 0, or 0 is divided by x. We could do the same thing. Or since we have no terms now and we need 2, the easier thing to do is just bring down the next two terms. Either way, if you go through the process again, you would still get x minus 5 in the next step, but it just saves you a little bit of time and energy because you have 0 there, but we still need to have two terms because we had two terms up here to do our division. So now we do this x because these zeros really just go away. So really we're just dividing into x minus 5 now. So x divided by x, careful here, lots of people think that's 0. X divided by x is not 0, it's 1. So I need to put a plus 1 at the top. 1 times x is x. 1 times negative 5 is negative 5. I draw the line and change my signs. Good thing I do, because then when I combine them, I get 0 and 0. So I have no remainder in this one. So that means that the answer to this problem is 2x squared plus 1. So really, in this case, again, we have no remainder. We've found that these are both factors of 2x cubed minus 10x squared plus x minus 5. So that problem is equal to x minus 5 times 2x squared plus 1. We call this the factored form. And this should look similar to some of the polynomials that we were graphing. Remember, our goal here is to try to get from standard form back into factored form or intercept form, because then we can graph our polynomial. Graphing it from standard form is pretty obnoxious with all those terms in it, but graphing it from factored form or intercept form, as we saw the other day, is a lot easier. So that's why we do this, is to try to get back to this factored form so that we can make a graph. Thank you for your attention. I hope that you have a wonderful rest of your day, and I look forward to seeing you in class again soon. Until then.